blood typing is an important topic for this chapter. I'll ask you some questions about it in lab, and it's the written portion of the exam. And so it's covered in these slides, in this part of the lecture. Let me start So let me read what I have in my slides. A blood transfusion is when, you transfer blood from one person to another for whatever reason. Chemotherapy patients need to be transfused, trauma, you need blood transfusions in an emergency. When they first attempted it, they observed immediate or delayed agglutination, and hemolysis of red blood cells occurred, leading to death. And I should probably put an exclamation point after that, so you can see why it's important. Mistakes can be made even to this day, and it can lead to death. So it's very important to know how to type blood before you give it to someone. It was soon discovered that bloods of different people have different antigenic properties, so the antibodies in the plasma of the recipient of the donated blood will react with the antigens of the RBC surfaces of the donated blood. All right, so that right there, I know it's early in the morning, but turn your brain on right now, because this topic causes a lot of confusion for a lot of students. It doesn't matter how clear I teach it. I know how to teach it. The point is, can you process, can you figure out how to solve these blood typing problems? You have a chance to do it in lab, you have a chance to do it on the test. Now, this next slide, I don't expect you to know these numbers, but there are different blood types based on the ABO system and the Rh antigen over here. And you can see the percentages. But don't worry about knowing those. Know this, that when we talked about the fractions of blood, you have the plasma part, and you have the red blood cells. In this lecture, when you donate blood, you donate the packed red blood cells. That's what we're going with. Donor's blood, you donate only the packed red blood cells, and then when you give it when you re-infuse in the recipient, you just suspend in a sterile saline. Usually that's what people need when they're transfused. They need the oxygen carrying capacity of the red blood cells. So keep that in your mind. And the other thing to keep in mind is, when blood is fractionated, the antibodies are in the plasma component, and the antigens on the RBCs that cause the problems, they're on the red blood cells. Because if you're receiving someone else's blood, your immune system is designed to attack non-self. Okay, now, I haven't taught immunity yet, but that's not too hard a concept to get. Cells from other people are going to be rejected by your body. Okay? When you get a virus or a pathogen, bacteria, anything that's non-self is seen as pathogenic by your body, and you attack it. The same thing is when you receive a bag of blood from someone else. It's that we don't want your immune system to attack you. Your immune system are the antibodies that are floating in the plasma compartment. So whatever antibodies you have circulating in your blood, if you receive someone else's blood, you have to type it correctly so that there's no cross-reaction. Okay, that's basically the heart of this lecture. So this next slide kind of says that. Blood typing prevents a transfusion reaction. So again, what's a transfusion? When you infuse blood, okay, you're just injecting blood into someone. So a transfusion is between different people. The donor's blood is attacked by the recipient's immune system. So the antibodies will cause agglutination. So these are all the things that can lead to death, basically. Okay, that's the only thing you need to know. Agglutination may lead to death. Here's a picture of it. Here's donor, recipient. Maybe this will help. So basically, let's say you're the donor. And you donate your blood, it's a good thing, and the blood bank, they try to do a good job in making sure it reaches hospitals and other places correctly. The red blood cells, they illustrate all of these like triangles. On the red blood cell. Those represent the surface antigens. These are the word antigen is a word that means antibody generator. It's the thing that can be attacked by the immune system. It's how your immune system kind of recognizes self from non-self. Okay. So maybe in this person, the donor, they have these red blood cells, and maybe they have other antibodies that have different shapes. In their plasma. So maybe this round shape won't attack a triangular shape. Maybe a square shape won't attack a triangular shape. See what I'm getting at? Your own immune system won't attack you. That makes sense, right? If your own immune system attacks you, you're going to have problems. It's called autoimmune response. So generally speaking, a person will have antibodies, but not against yourself. Okay. But you have these surface antigens that allow your immune system to kind of tell self from non-self. So that equals, that triangle is self for this person. But let's say there's some other person, the recipient, who's going to get this blood. Use a different color here. Maybe the recipient's red blood cells, maybe they have circles on them. Okay. But maybe in their antibody collection that's circulating, maybe they have antibodies that will look like that can fit a triangle. Okay. So if this person receives this blood, what's going to happen? Now this person has this blood circulating in their bloodstream, and they have the antibody that will attack it, that will recognize it as non-self. So that's the problem. That causes what you have there, a cross-reaction. The fancy word is agglutination. Okay. It can clog up your kidneys, it can lead to death, and so the whole point of typing is to bypass that, to give someone else's blood so there is no cross-reaction. It's not that hard to do, but people still make mistakes. Donating blood is okay if the donor's RBCs do not have the antigens that will react with the recipient's antibodies. Okay? When I give a lecture, there are some sentences that are more important than the others. That's probably the most important sentence. If you can understand that, I think you'll be okay with the entire lecture. So if you're donating blood, you consider the antigens on the RBC surfaces. If you're receiving blood, you want to know what antibodies may be present. because that's the thing that will cross-react with the blood being received. Okay. So I mean, this right here, right? For donating blood, I said already, what do you donate? The plasma or the crit? The crit, the packed red blood cells. That's what you donate. Of course, you can fractionate blood, and they keep the buffet coat, they keep the plasma, they keep everything. But for this lecture, donate the packed RBCs. That's usually what we're talking about. If you're the recipient, of course, you have red blood cells. We're concerned with the immune system. Is the recipient's immune system going to cross-react with the blood they're receiving? Now, there are two different types of systems. There's a billion different antigens you could talk about. In blood typing, there seems to be 3. You just have to keep track of 3. That's it. So let's go through all the blood types. Hold on, let me keep this placing my pens. Okay. When you hear about the ABO system, it's a very common one. Maybe you've heard of it already. Like for example, if you have type A blood, that's a type. But that simply means the A antigen is present on your RBCs. All right, well then, type B means the same thing. B antigen present. Type O, it's like 0. A and B both absent. You don't have either. So O is not an antigen. It means A and B are absent. But that's a type, right? Where A and B are not there. There's a third antigen, that's the RH system. It's called RH. It's first discovered on rhesus monkeys, I think. Sometimes it's called type D. You ever see the letter D? It refers to RH. I typically just use RH. Anyways, the RH antigen, they kind of use this plus minus thing. Okay. So what we say is, for someone who is RH positive, that means the RH antigen is present. You guys are smart. What does RH negative mean? It's not present. Okay, very simple. How many antigens are there? 3. What are they? A, B, and RH. And they're there or they're not. And that's pretty much it. Okay? So, I don't know if, after teaching this for a decade and a half, it still causes confusion because of the plus minus thing and the AB, because you have to combine them. Okay? So, I think what will help is, let's list every single blood type and go through what's on the RBC and what antibodies should be present in their blood. How about let's just start with, let's do this. Let's go with, let's say, just to use symbols, let's say a triangle will represent the A antigen. So let's say that the antibody that fits that triangle shape will represent an antibody against A. Antibodies are your simplest ammunition of your immune system. Okay, they bind anything that's non-self, they clump it up, and other cells can get rid of it. So it's your defense mechanism. So an antibody against the A antigen exists. All right, let's say, let's use, how about a circle for B antigen? Let's say a circular shaped antibody will be the B antibody. And don't confuse antibody and antigen, right? It can be confusing. Sometimes if you see anti-B means the antibody against B, sometimes that's presented that way. I'm just saying B antibody. The anti-B usually means antibody against B. Well, anyways, the third one is RH. Let's use squares. So the antigen RH is a square, but the square-shaped antibody is RH antibody. So let's use that system for clarity. So let's say your type, let's go A negative to start with. Your A negative. What does the negative mean? RH not there. What does the A mean? A is there. Is B there? No. Is O there? O doesn't, what does O mean? So basically of our three, which one is present? A. I'll just go like that, right? That means type A. Now what you should assume as a clinician is, well, if you have the A antigen, you're not going to have the A antibody, but you'll probably have the other two. You'll probably have the antibody against B and the antibody against RH. You should assume that. Okay. You don't have the antibody against yourself, but you have the other two. That's the exercise. So that having been said, type A positive. Which two antigens are present? A and RH on the RBC. So then which antibody should they have? Probably the one against B. B antibody, so I'll just draw that. Right, so then the other types, how about type B negative? So then you have just the B antigen on the RBCs, well, and then the other two, the antibody against A and the antibody against RH. Okay. So then type B positive, you have the B and the RH. So I'll draw circles and squares. And then they would have the antibody only against A. Okay. So let's do type O. Let's do O negative. They don't have any antigen. They don't have the A or the B because that's what O means. And what does negative mean? RH is absent. So they don't have all three, so I'm not going to draw anything. But you could assume that they have all three antibodies. The one against A, the one against B, and the one against, what was that? B is the circle. Let me draw more circle-ish. And the one against RH. Right, this is a special type. They call this the universal donor. I don't like the word universal. Well, amongst humans, I guess, it's universal, but well, what does it mean? What makes this person a good donor? They can donate to any other type. Well, there's two things to consider. Is it the red blood cell or all these antibodies? When you donate blood, what do you donate? The crib. That's this. Why is that good? Whoever receives it, there's nothing to cross-react with. There's no antigens to cross-react with. Okay, so, you know, O neg, that's why you're a good donor. Who could you receive blood from, though? Only O negative, because it's like, well, you got all these, and so that could cause problems if you receive any other blood type. Okay, so then what does O positive mean? Which one antigen is present? The RH. So I'll just draw squares, and we have the other two. The antibody against A, the antibody against B. That's O positive. There's one other type, it's very rare. There's AB positive and AB negative. Let's do AB negative first. So then, for that one, the A and the B are present, so I'm going to draw the triangle and the circles, and then they're negative, so okay, I'm going to draw the antibody against RH. So then there's AB positive, that's the last type, AB positive. So we're going to have, well, all three antigens are present. The A's, the B's, and the RH. So I'm drawing triangles, circles, and squares. Now sometimes on the written part of the exam, students like to use the shapes, and that's fine, but you have to define what they are, like I did, right? Because in reality, they mean nothing unless you tell me what they mean to you, okay? And you can't say, well, it's what you use in lecture. You're not giving the lecture, I am. I don't even know if you're here today, okay? So if you use the symbol, that's great. Define what they are just like I did. What antibodies does this person have? None of them. None. No antibodies against AB or RH. No ABs against antigen A, B, or RH. Huh. That makes this person a great recipient. Well, we'll call that the universal recipient, this blood type. What makes them a good recipient? Which fact? The fact that they have all the antigens, or the fact that they have no antibodies against these three? The no ABs. Because that's the thing that, if you receive blood, that's what you're worried about. You can receive any blood type. This is a very rare blood type. It's just good to know about it, though. I'm going to go back to that slide that had the percentages. All right, so the ABs, you can see, is a very low percentage. And most people are RH positive. So a very low percentage of people are AB, and there's a very low percentage of people who are RH negative. So it's very rare. But let's know about it, okay? So those are the types. Do you have any questions on what I just did? We just went over all the blood types. It's nothing good. Well, I don't like this figure because what are they not showing you? The RH, antigen D. That's why I kind of don't like that. But it's the same thing for the ABO. So here's kind of like the process I think students should go through when I ask you blood typing type of questions. So I'm saying John and Peter, random people. It's type AB. And then I got Peter, type A positive. Now, you know, the basic idea is for students to understand, can this person donate to that person? You got to know their blood types. So before we answer this question, we must first consider, who's the donor, who's the recipient? John is, very good. Okay. Knowing that, which choice would you choose? John's antigens, so A or B, which one is it, A or B? Peter's antibodies. B is looking good to me. Okay? All right, that's good. If you're walking late this morning, this will catch you up. Go through this thought process. For John's blood type, since we said, okay, consider his RBCs. What is present of the three? The A, the EB, the RH. What's present? The A and the B. So I'm going to I want to stick to my triangles, which are?
An A.
Very good. And circles, which are the B's. Okay. Now, I mean, just for fun, how about, let's just say, which antibodies are present?
RH.
The one against RH. But we don't care about that. He's the donor. We're donating the crit. All right, well, let's see. Okay, so we got that one. I guess it was B was correct for this choice, for this question. So for Peter's blood type, the antibodies in his plasma, let's just do the whole thing. For Peter, he's A positive, so that means present in his RBCs, he's going to have the A's, triangles, and the squares, boom. For his antibodies, he's going to have the one against what? B. I want to draw the circle. Antibody there. Okay. All right, so before we kind of look at the choices, let's just kind of draw what's going to happen. He's going in this. You see the problem? Is there going to be a problem?
Yes.
Yes. If John gives his blood to Peter, Peter's antibody against B will attack John's B antibody, or John's B antigen. See, even I mix them up too. So let's read the choices here. A couple of yes, a couple of no. Well, it's no, but which no is the correct reasoning? No, because, well, let's see. This one looks good. John's B antigen will react with Peter's B antibody. And you see how I've worded it? It's very important that students can tell me that you know what cross reacts. Because obviously, just yes or just no isn't enough. So when I grade this, I usually make it out of like 3 or 4 points, because there's some wiggle room for reasoning. You could get the yes, no. Let's say you get the yes, no incorrect. 1 is 0. That's easy, as far as grading. But let's say it's the correct no, but then you put incorrect reasoning. Then it's like maybe 1 out of 3, 2 out of 3, depending. Okay, so there is the reasoning. It's very important that students understand what cross reacts. And the confusing thing is the whole antibody or an antigen. Don't mix those up. I see that happen a lot. And if you can keep the terms straight, then I think you'll be okay. All right, so let's see here. Why don't you do Betty to George? Give me a couple of minutes. Just go, talk amongst yourselves, see if you can do it. Same kind of thing.
Now for the Betty George thing, it's pretty obvious. A's can't donate to B's. That's obvious. But let's go through the reasoning. Who's the donor? Betty. Okay, but the student in this class needs to express the correct logic, right? It's no, but why is it no? I just always write it out. I go through the whole thing. I don't skip steps. Okay, A negative, you got the A antigen, probably have antibody against B and RH. Negative recipient, I don't skip steps. B positive means they got the circles and the squares, and they probably have the antigen against A. But okay, this is the donor. Boom, boom. Oh, that's a problem. So the answer is no, because George's A antibody will cross-react with Betty's A antigen. So, who wouldn't mind sharing? How many of you kind of got that? Give me a halfway hand raise. Okay, it's about half. Usually, at this point, half you get it, half you're going through a process of trying to understand it. That's okay. All right, well, anyways, explain why AB positive is the universal recipient. Always remember, what makes you a good recipient? No antibodies against the A, the B, or the RH. Oh, negative, why is that type of universal donor? What makes it a good thing to donate? No antigens. There's no A antigen, B antigen, or RH antigen on the RBCs. Okay. Let's try to come up with some generalities. Let's see here. So look at this table. Look at on the top and along the side. What are they trying to do here? Donors on top, recipients on the side. The checkbox means it's okay to donate. Okay. So what are the general rules? Well, let's look at this first box. Oh, an O positive can give or receive to an O positive. That makes sense. So the first thing you learn is that people of the same blood types can give blood to each other. That's obvious. Same types can give to each other. Let's get the obvious out of the way. Let me ask you this question. Can RH positives donate to RH negatives? Let me just put that on the board. Can positives donate to negatives? Question.
No.
The answer is no. Let's look at the table. Where do you see that? These first four are my positives. Here are my negatives. See this big vacuum? Positives cannot donate to negatives. And why? It's the same logic for everything. It's the whole antibody antigen thing. If you're RH positive, let's just consider the positive, nothing else. What is present? What is present? RH antigen on the RBCs. But if you're negative for RH, you don't got the squares, but you probably have the antibody against it. Ah. So you see the problem? This is why positives can't donate to, it's always this. It's always this. Now that is always the logic. So let me ask the question again. Can negatives donate to positives? And it's always the same logic. Always the same logic. If you're negative, just for RH, not considering the ABO system, do you have the squares?
No, you don't. So it's like, if you're positive for Rh, I mean, that doesn't matter. I mean, whether you have the antibody or not, you're getting negative blood. Blood that is negative for that antibody. So it's always the same reasoning. So what's the answer? Yes or no?
Yes.
The answer is yes, and let's look at the table. I said, can negatives donate to positives? So if you're negative, it looks like you have check marks, you know, in both positive and negative. So if you're negative, you can donate to either positive or negative because you don't have the antigen. So, you know, you can kind of stare at this a little bit longer. Like, for example, what the heck is this going on here? That's the same blood type thing. Okay, that's why it's checked off all the way there. Well, what is this one, this horizontal line? What is that? Why is that checked every single time? Universal recipient, AB positive, super rare blood type. What the heck is going on here? It's checked every time. Universal donor. Okay, so that's a useful table. Now here's what you can expect from lab. Patient comes in, they're losing blood, they're going to need blood, and you're getting out of O negative. What do you do? Well, you got to find out what type they are. So on your lab, the blood typing lab that I want to do with you guys, I'm going to postpone it to Monday, because remember, Friday I'm not going to be here. But there is a substitute, so class is not canceled. So come to class, very important attendance day. I think I already mentioned that already. Come to class Friday. I'm sure that's clear. So your lab on Monday will be the type unknown. So it's fake blood. We don't use real blood anywhere. I don't like that. Fake blood. But anyways, in a real clinical situation, you have to type an unknown. So what do? You don't know what's there. An easy test is just test for the presence or absence of each of the three antigens. Typing unknown blood. The test is you're testing for the presence or absence of A, B, and RH antigens. What you're going to do is in your lab you have sera with antibodies against A, antibodies against B, antibodies against RH. And you just add it to the well and see if you get something, see if you get a reaction. So let's do number one together. You got your three test wells. So I'm drawing test wells, and you put the blood in it. Okay, you put the blood in it. It's hard to draw. You got the unknown blood in all three. Then you add the antibody against whatever. So for example, if you add the anti-A serum, what you're adding is, wait, I use triangles, right? For A, yeah, thank you. You're adding anti-A serum. You add that to the well, right? Nothing happens. No agglutination. It's a negative result. I'll just put negative. No, negative for agglutination. That's the result. What's your interpretation? You would say, for example, if this were the oral quiz, and I said, interpret that result, how would you phrase it? Yeah, which one? Yeah, there's different ways to say that's the correct way. Just say A antigen is absent. That's what I would say. Isn't that what that means? You added the antibody against A, and nothing happened. That means A antigen absent. So they're not type A, so you know that. Move on to the next one. What did you add to this well? Antibody against. See what shape is that? Circles. Let's go ahead and boom. Agglutination. So clumped up. Clumpies. Positive for agglutination. So how do you interpret that result? Oh, okay, well, the B antigen is present. So type B. All right, move on to O. Anything there? Here, negative. I'll just go neg. No agglutination. So what's the blood type? Type B negative. Right? I did one with you. Type number 2. Just shout it out. O. Positive or negative? Positive. Number 2 is O positive. Okay. Let's go through the reasoning. What is that result? Positive or negative for agglutination? There's no agglutination. Negative, negative. So, if A and B are both absent, what type are they in the ABO system? Type O. What about the RH system? Okay, let's do this. Just do 3 and 4. I'll check back in 20 seconds. That's how long it should take you. Type 3 and 4. And you can talk, this is not a quiz. In Monday's lab, I will give you an oral quiz, but that's not now. All right, what's 3, number 3, what is this here? What type is this person? B positive, okay, that's B positive. B is present, RH is present. How about this one? O negative, okay. So that's how you type. You just, those 3 antigens, they're present or they're not, and you just test for the presence or absence of the antigens. One clinical situation, for example, now that you know this, it's called erythroblastosis fetalis. Let's say mom's RH negative due to genetics, fetus is RH positive, unless they got that gene from dad. And so basically, well, in the placenta, there's a separation of the RH negative blood and the RH positive blood. However, there's a lot of bleeding during birth, and so maybe mom is then now exposed to a bit of RH positive blood. And so, well, that baby's going to be okay because it's during delivery, so the baby's gone. But now over time, now mom is exposed to the RH antigen. She'll produce antibodies against RH, shown here. And so you kind of worry about that with baby second pregnancy, who is also RH positive. Those antibodies can cross the placenta and cause the condition erythroblastosis. I mean, obviously, you could prevent that easily. You could administer Rogan, simple question-answer thing during the second pregnancy. Anyways, disregard the physio-X blood analysis. I'm not going to assign that. But
for right now, I'd like to move on to blood clotting. We'll have other opportunities to work on blood typing, but I have to press forward. So I'm going to these slides here. Blood clotting is at the end of these slides, but I want to talk about the formation of white blood cells and the platelets first. Okay, so here's a picture of the hemocytoblast. Shifting gears here. I want to teach you how the all the formed elements form. Here's a slide on bone marrow. Think of it as squeezing blood cells from bone, because that's where the bone marrow is. But the output is astronomical. The billions of RBCs and platelets that are produced, you can see the lifespan of an average cell. So the bone marrow, with spleen and liver, it's the major site for removal of aged and defective RBCs. But I really don't want to talk about that. I want to talk about how they're formed. Here's a picture of bone marrow. And you can see that there's these white spots which represent adipose, and then all the purple cells, the cellularity. And as we age, the adipose kind of takes over and the cellularity kind of declines. So the goal of bone marrow is to produce all the blood cells. Now, this slide just shows the formation of just the white blood cells. It does not show the platelets or the RBCs. So to remind you of that, we did talk about it. So from the hemocytoblast, in terms of the presence or absence of EPO, iron, folic acid. Remember I talked about all of those blast stages, the urethral blast, normal blast. Reticulocyte. You get your mature RBC. So we did discuss how the red blood cells form. You know, in terms of the platelets, from the hemocytoblast, there's, I'm just going to call it TPO for now. That's short for thrombopoietin. Anyways, that can stimulate a cell called the megakaryocyte. And from that cell, you're going to get your thrombocytes or your platelets. This is all in the bone marrow. This slide is showing you the formation of the white blood cells. So from the hemocytoblast, you're going to get these colonies called granulocyte, monocyte, colony-forming units. Let me write that term down. Granulocyte, monocyte, colony-forming units in the bone marrow. These little clumps of cells, these little colonies of cells. Colony forming units. So for example, on this slide, it's probably all of these committed cells up here, but I'm not going to like write all those different cell names. I'm just going to say they're colony forming units, and that there's this GM-CSF. Use a different color. It stimulates these GM-CFUs.
which stands for granulocyte monocyte colony forming unit. So maybe you can guess what this stands for. Granulocyte monocyte colony stimulating factor. It's a molecule that can stimulate these colonies to form. Okay? Just much like TPO will facilitate the formation of a megakaryocyte, and EPO is a hormone that will cause the formation of the RBCs. So basically, in each case, you need some kind of factor to help form all of these cells. You need EPO for the platelets, and boom, you need TPO for the platelets. Oh, okay, well, anyways, for these granulocyte monocyte colony forming units, what you see here is there's a line that will, out of those colonies, you'll get monocytes. MCSF, monocyte colony stimulating factor, and you'll get the monocytes. And if there's a granulocyte colony stimulating factor, out of those DMCFUs, you'll get your other three. The granulocytes include the eosinophils, the basophils, and the neutrophils. Notice that the monocyte, when they circulate in the blood, if they're attracted to an infection, they leave the bloodstream and enter the connective tissues, and they become macrophages. So monocytes can become macrophages. So I've described everything up for all of these white blood cells. I won't add lymphocytes to my board drawing because I'll talk about those when I talk about immunity next week. Okay, let's move on for now. Let's talk about the white blood cells and some of their basic functions. Here's pictures of them on a blood smear slide. And I don't know if I mentioned this before, never let monkeys eat bananas. It's a nice little phrase to help you remember the prevalence of each one. So you have, of all of these, mostly you have neutrophils, then lymphocytes. Basophils are the hardest to find in a drop of blood. Here's some notes on neutrophils and eosinophils. I give you some basic facts on their function and also how to identify them, okay, on a microscope slide. So the neutrophil in terms of function, they're your major army of phagocytes. So phagocytosis is cell eating. You destroy foreign molecules in your body. So they're a phagocyte. In terms of their appearance, what I notice most is they have this multilobular nucleus. I don't know why. That's how I always am able to identify them. And look at the color. I won't try to describe the color. They're kind of that nice lilac purplish color. Multilobular nuke. The granules, you can't really see them too well, but these are considered granular. Remember, look in your notes, I defined cells that are granular and agranular. These have the granules. The granules are filled with defensive type molecules. Okay. Well, the eosinophils, that means red. Look for a nice red cell. Takes up a red stain. And I'll start with their nuke. You always see this characteristic bilobed nuke. 2 lobes, one here, one there. Bilobe nuke. And these nice red staining granules. You can see them quite clearly when you identify them. Here's what a lymphocyte looks like. Now, when I teach about the lymphocytes, there's the B and the T, and you can't tell by looking at it the function. But the nuke is so big, you barely see any cytoplasm. The nuke is so big and dark and purple. I'm using black, but you have just a little rim of cytoplasm. Large round nuke. I won't say anything about their function. I have a whole lecture on the B and T lymphocytes. I just want you to know that's what they look like under the scope for now. In terms of monocytes, you have a kidney-shaped nuke. Their main function is, well, I said it already, they're a precursor to the macrophage. They become macrophages. During an inflammatory response, let's say. Okay, they're big cells. Okay, I do give you the microns of diameter. These are bigger. Okay. I would say they're the largest diameter in terms of looking at them versus other white blood cells. Basophils. Oh, I just erased you. I forgot one note. Add this to your notes for eosinophils. I wanted to also put, they fight parasites. Okay, so for eosinophils, add to your notes. If you see elevated levels of eosinophils, you might have a parasite, like a tapeworm in your guts or something. Usually not a problem in westernized nations, but that's something I usually like to say about those I forgot to mention. All right, so for the basophils, they stain this super dark purple. Their granules stain so dark you can't even see the nuke. So I'll just say the dark staining granules obscure the nucleus. Can't see it. Well, anyways, they secrete histamines. Histamines cause the swelling, the drainage when you have allergies. It's very uncomfortable, but those molecules are attracting fluids to the area of infection to kind of flush out the pathogen or the allergen. So those are basophils. Okay. So now you know the basic function of some of the white blood cells. Now we're going to learn about another function of blood, is its ability to clot or coagulate, to prevent shock. There's a picture of blood coagulation. It looks like a spider's web. See all those white fibrous threads? That is the hallmark of blood coagulation. Because once you get that net-like structure, blood cells become trapped in it, and that's coagulation, and that'll prevent bleeding. Okay. Shock is a lack of blood flow, so blood coagulation can occur, can prevent shock. So there's different causes of shock. For whatever reason, the blood's not circulating. Maybe you're using blood. Maybe the heart's not pumping. You have an acute MI. If you can't keep the blood pressure up, that'll cause shock. Vascular or neurogenic shock. The peripheral blood vessels, the arterioles, maybe they dilate too much. Maybe you have a head injury. Okay, and remember when we studied the medulla, those centers in the medulla? You know how they always check for the pupil dilation? And they always say, oh, the pupils are fixed and dilated. You know, why is that a bad thing? It's because that's a sympathetic response. So that means the cranial nerve is damaged. That means you may have damage to the brainstem. That may mean this kind of shock can occur. If you have damage to the brainstem, that's where the sympathetic efferents are. And if your body can't constrict the arterioles, they dilate too much. So then I put this up here to remind you. You do have an online test on blood pressure. If those dilate and you let all the blood out of the arteries, that's it. Blood pressure is going to plummet. That causes shock. So they call that vascular neurogenic shock. Those sympathetic efferents don't work. There's another one, hypovolemic shock. You're just losing blood. That's the most common form of shocking. We even talked about this too. Blood pressure starts to drop after about 20% removal of blood. So let's kind of talk about how the blood can kind of maintain homeostasis with hemostasis, which is another way of putting blood coagulation in another way. It just means still blood. That's what the term means. Well, anyways, this would occur at the injury site, these three phases. I'll teach them in order. Know that they don't necessarily have to occur in this order for a blood clot to form, but I will present them that way. Okay, so you have a damaged vessel. That's step one. When you damage a vessel and you cut through all the tunics, the tunica media, it tends to spasm. Here's a picture of it that shows it better. Step one. Vascular spasm. The picture shows that when you cut, there's a spasm right there. It's a vasoconstriction event. Now remember your tunics, TI, TM, TA. Which tunic has the smooth muscle cells that will spasm? The TM. So that's what we're talking about there. That'll increase resistance to blood flow. That'll help minimize the blood loss. So this is what the blood vessel does. You can help by applying pressure, right? By applying pressure, you're helping that. Pressure to the wound. Well, and the other thing that happens is that a platelet plug may form. So what happens is this step two, platelet plug formation. You have a cut. Now the flowing blood, there's all these collagen fibers from the underlying tunics. So platelets may stick to the exposed collagen fibers. So that's what's said here. I want to show you another picture of the platelet plug. This is kind of a precursor to the fibrin mesh. And it doesn't always happen. Well, when it does, let's learn where platelets come from. I mentioned it before. They're circulating in the blood, but they come from the bone marrow. TPO thrombopoietin will facilitate the megakaryocyte to flake off platelets. What platelets literally are, they're basically bags of cytoplasm from the megakaryocyte. So they're not true cells. They're just flakes of this mama cell, the megakaryocyte. Okay? But that is what is circulating, and that is what is helping plug the leak early on in blood coagulation. So here are some features of the platelet. They don't have a nucleus, but they have most other organelles. Their membrane are just basically closed packets of cytoplasm, but they have a very well-developed cytoskeleton because they have to plug leaks. So the cytoskeleton is very important for them. They have many membrane proteins to help stick to each other for good adherent capabilities. The important thing about them is they contain a lot of chemicals important for clotting. So one thing to note about platelet plug formation, when they stick, they become activated. The activation process involves a couple of things. One are just morphological changes. Let's say this little fragment represents an unactivated platelet. When they kind of bind and adhere and become activated, they get big and they puff up, they get all big and spiky. That's activated. That allows them to stick better, and the other thing they'll do is they'll secrete chemicals that attract more platelets. I'll write that. Secrete chemicals that attract more platelets. I don't think they're considered enzymes, but I have them on the next slide. We'll list some of them.
So if it tracks platelets, does that mean platelets have some type of cilia to move them around?
It's like chemotaxis, so molecules that are secreted, the platelets that are circulating chemotactically find their way to the vessel that's injured, so it'll stick more. Where is that slide at? Did I delete it? Oh, here it is. Here's a picture of the platelet plug. These guys are plugging the leak. These guys are have been activated. They're all spiky looking. These guys have not been activated yet. So the release of chemicals that I want you to list are right here. Sorry for skipping around. I'll go back to what I skipped over. The chemicals include ADP, serotonin, and thromboxane A2. Let's just list those. ADP, serotonin, thromboxane A2. What these will do is, well, look what they do. They're aggregating agents, and or they promote more spasm. So they're basically attracting more platelets to the area that's been injured. So these chemicals, put those, if you want to fill in this box, the release of chemicals are ADP, thromboxane A2, and serotonin. They facilitate more platelets to aggregate. This is considered a positive feedback. Plus positive feedback. Let's remember what that is. Positive feedback is the stimulus enhances the original stimulus. So if you secrete chemicals that facilitate aggregation, then those other platelets that are attracted will secrete more chemicals to attract more platelets, to attract more chemicals, to attract more platelets, and it just keeps going until you plug the leak. Okay, so that's positive feedback. So that's important for this slide. So let's take a look at this slide for a second there. Let's go back to step one. What was step one that I presented? Spasm. And I wanted you to see that on this picture here. See these cells here, the tunica media? They're all kind of like smaller, uncontracted, but when they contract, they bulge. So do you see that there? The bulgy, smooth muscle cells. They're trying to minimize the blood loss. And these kind of plug the leak there Okay, so that's kind of what's going on there. The other thing I wanted you to know is that this aggregation is restricted to the site of injury. There are neighboring uninjured endothelial cells that will secrete prostacyclin and nitric oxide to restrict aggregation just to this site, nowhere else. So let's note that. Uninjured ECs, endothelial cells, secrete nitric oxide, NO, and prostacyclin to restrict aggregation to injury site. Aggregation. All right, so we got step 1, step 2 covered. Any questions on the spasm or the coup de grace? We'll move on to step 3, which is the coup de grace of blood coagulation, the fibrin. Okay, all right, so that's the coagulation part of blood coagulation. Well, it turns out this step 3 has 3 phases here that we outlined for you. 3 phases of fibrin mesh formation. The platelet plugs, they're kind of like a loosely knit thing, but when reinforced by fibrin threads, it becomes a very strong clot to stop the bleeding. So let's kind of go through this. There's a couple of pathways. The goal is get those fibrin threads. They're circulating in your blood as fibrinogen, but they're soluble. You got to get them to, come out of solution. You always remember in chemistry, you always have to get that precipitate, get something to come out of solution. Usually add alcohol or, well, I don't know. What are you talking about? I hate chemistry. Well, the point is, things come out of solution. That's what we're trying to do here with fibrin. Okay. You get a little bit quickly, so you can kind of stop the bleeding a little bit earlier, then you reinforce it later. So you got early, late stage, get some quickly, get some more later. Okay. We've all experienced, you slice your finger in the kitchen, it's bleeding, you clean it, and it seems like it's forever. It should stop bleeding after several minutes. If it doesn't, you probably want to go to the ER and get that stitched up. But anyways, we have 2 pathways to get fibrin. One quickly, one not as quickly. Now just in terms of number of steps. Which one looks quicker? Extrinsic or intrinsic? Extrinsic, good. So this is a cascade, and one you gotta know. So let's kind of outline it. Pathway is a little bit quicker, but this pathway, it requires vessel injury. Okay. Put that as a note here. Because when you damage a vessel, the flowing blood, it kind of sees this tissue factor. Tissue factor is secreted by the injured cells. Flowing blood. I'll put C's in quotation marks. I mean, it's not eyeballs, right? Tissue factor. The tissue factor is abbreviated TF on the intrinsic pathway. Well, anyways, okay, so that's like, you got your smooth, continuous, and then you got a break. Well, you have a vessel injury. The flowing blood sees the tissue factor. Now, the intrinsic pathway, let's go over here for that. It doesn't necessarily require vessel injury like the extrinsic pathway does, because the intrinsic pathway is, that's why I put this picture, it can happen just by blood sitting still, reacting with the charged molecules on the glass tube. All right, it happens intrinsically. It's a little bit slower, there's more steps. But in this example, let's say they're both happening as a result of vessel injury. So let me draw kind of a break in the vessel here too. I mean, assume it's the same thing, but let's just kind of separate them like they do in the figure. All right, so there's a few dozen clotting factors. I only present several of them. But it's like the cranial nerve thing where they got the Roman numerals and they got names too. And I use them interchangeably, but let me refer you to a table that's got them all listed for you. Chapter 17, clotting factors. 661 in this book. There's a table of the blood clotting factors. It's got the factor number, it's got the factor name. It's all good. You can look it up if you need to. 661. It's got them all listed out. No matter what I use in lecture, know the name and the number, just like the cranial nerves. All right, so to simplify this, let's start with this. What's important are these complexes. So what happens in the extrinsic pathway, the tissue factor, it complexes with 7, VII. Okay, so I'm trying to draw the complex at the area of infection there. There are other factors that come into play. For example, calcium seems to be important. Calcium is known as the universal activator. But anyways, okay, so that's one side. You get the complex here. Now this other side, the complex that's important is factor 9 and 8. 9 is plasma thromboplastin component, and 8 is anti-hemolytic factor. Let's just go with 9 and 8, IX and VIII. And now there's a lot of steps to get to that. It looks like you needed 12 to activate 11, and 11 to activate 9, and you also needed calcium. So 12 to 11 to 9. 12 got you to 11, got you to, what got you to 9? And calcium was also important there too. So I'll just draw boom, boom, boom. Assume this is both happening simultaneously, but what if we say which one happens faster? Yeah, this one happens a little bit faster. But you know, they both kind of merge onto what's called a common pathway. What these complexes will do is they activate factor 10, which is called prothrombinase or prothrombin activator, factor 10. Okay. So this is a common pathway. To this factor 10, which will then get you to your prothrombinase or prothrombin activator. Just pick one, know them both. Prothrombinase. All right, so let's talk about this common pathway a little bit more. We're almost there. Let's just kind of recap. We got extrinsic and extrinsic, intrinsic, X in. Okay. All I'm saying here is what we've been saying all along. You need the tissue factor for this one. The flowing blood sees the tissue factor. It's a little faster. It's a shortcut to get to factor 10. The intrinsic pathway, a little bit longer pathway to get to factor 10. So here's the common pathway. Here's our prothrombin activator. What it does, it takes clotting factor 2 prothrombin and converts it to its active form, thrombin. So let me write on the bottom of the board here. So prothrombinase is an enzyme that will convert prothrombin to thrombin. That's the active form. That is clotting factor 2. I'll put a Roman numeral 2. I'll be honest, I'm like you. I can't stand the Roman numerals. But at least 3, 2, 1 is easy, right? Or maybe I'm wrong about you. Maybe you love Roman numerals. I don't know. I only like them for the Super Bowl. That's about it. They have very little use in our culture. I wish the anatomical sciences would lose them, but I think we're stuck. Let's get the thrombin. Will get you your clotting factor 1. So thrombin will convert fibrinogen to fibrin. That's our clotting factor 1. Okay, that's your fibrin threads right there. That's your insoluble chromatin solution thing. So that's the end. Because once you get that, the blood cells get trapped and they become clogged and you get your cross-linked mesh as they see on the slide there. So the common pathway is from here on down. Okay? You can see that the two pathways merge to the one pathway. Sorry, my mic came off. Both pathways localize the effects of factor 10 to the site of injury. Both pathways respond to Bissell injury. It's just that extrinsic is kind of faster. Okay. Also, PF3 is needed for the intrinsic pathway. I haven't added that anywhere on your board notes, so maybe I want to put that in the margin of your notes. PF3, PF3, PF3. Platelet factor 3. But I did mention calcium a couple of times. These aren't necessarily clotting factors that get the Roman numerals, but they're important for these pathways. I think I haven't found a better picture of fibrin mesh. Okay, I've been looking. There's 44,000X, there's 12,000X with big plucky-looking threads. That's a nice picture of activated platelets. Okay, large, round, they're like big old ball bearings at 12,000X. But when they become trapped, that's a very good blood clot. So now we've accomplished blood coagulation. Great, now what? You have to repair the damage. So you have to repair the tunics. I just want to kind of give you a general idea of how that happens. I won't go into too much detail. Clot retraction. So this is like post-coagulation events. For example, if you have a gash and it's too big, you have to go and get stitches. What do stitches do? They just bring the tissues together so they can heal. So that's what's happening here in clot retraction. The platelets pull in the fibrin mesh, compacting for a tighter seal, helping to bring the damaged tissues together. Okay. All right, so the vessel repair process can then begin. I'm going to simplify it to a couple of things. No PDGF, that repairs the tunica media. Platelet-derived growth factor helps repair the smooth muscle cells of the tunica media. VEGF will help repair the endothelium of the TI. Vascular endothelial growth factor repairs endothelium of the tunica intima, the TI. Then what do you got to do? Well, okay, you repaired the tunics. Now you got to get rid of the clot. So you need a clot buster when it's all said and done. So that's called fibrinolysis. Clot buster. Plasmin is the thing. That's your clot buster. So plasminogen is the inactive form. The active form, plasmin. So write down TPA, TPAI. That'll determine whether or not this forms or not. If you need your clot buster, the one you want is TPA. TPAI would inhibit this, okay? So I'll put the inhibition sign. If you want to get rid of that clot, you want TPA. In fact, when I studied heart disease as a grad student, TPAI was a risk factor because that prevents the clot buster. And a heart attack is a clot where you don't want it. So let's talk about clots where you don't want them. Let me define these terms to finish. Clots where you don't want them have different names. Thrombus. So you have a blood vessel here. There's the vessel, and we'll say got a damage there. And that damaged tissue causes a clot. Let's say the clot partially occludes the lumen. That's called a thrombus. If it were a larger injury, and the clot occluded the entire lumen and blocked blood flow, that's considered a thrombosis. And this is one of the number one causes of heart attacks. But this occurs in one of the coronary arteries that you studied. Okay. Because then the flowing blood, it's blocked and the downstream tissue doesn't receive enough oxygenation and the tissue dies. That's a heart attack. That's acute MI, if it's the heart. It's a stroke in the brain. It's death of tissue wherever it happens. Call it a thrombosis. This only takes minutes. It takes decades of your life of an unhealthy lifestyle to develop heart disease. But a thrombosis event is acute, occurs in minutes. Thrombosis, sorry. Thrombosis. There you go. And other terms. let's say this top situation, a piece breaks off. The flowing blood makes a little piece break off of the one that's stuck there. And that little piece floating is called an embolus. That little piece floating there. But let's say it floats downstream as it goes to a smaller blood vessel. Oh, let's say in the pulmonary circulation. Pulmonary embolism is a common cause of death because you're blocking the vital organs there. So let's say it's a smaller blood vessel in pulmonary circulation. That embolus gets stuck. That's considered an embolism. So the anticoagulants can help. Here's a picture of just a few that we've listed in terms of clot formation or dissolving. It's all a matter of what's in circulation. If you have more TPA, aspirin, and heparin, which are blood thinners, that can help prevent these undesirable clots. If the scale tips more towards the clotting factors and TPA, AI, and other things, then you favor clot formation, depending on what's desirable in a given case. Okay, I just want you to know. It's all about tipping the scale one way or the other. Okay, that concludes the blood. Before you leave, I put the test online. I think you guys realize that now. But while I still have your attention, I wanted to show you some things on the schedule here. So we're right on schedule. We did lab practical 2. That says lecture exam 4. That's on Canvas right now. And it's available through tomorrow. 50 multiple choice questions. And any questions on lecture exam 4, which is on Proctorio? When is it due? Tomorrow. Okay. So Friday, I just taught blood coagulation. So for lecture on Friday, you'll be watching, it's called Forks Over Knives. And if you've seen it, come to class and watch it again. It's kind of that video will replace some of the chronic disease lectures I used to give in this class. It's an excellent, heavily researched, well put together movie, I think. And I think you'll enjoy it if you haven't seen it. For lab that day, I don't want to do this blood typing lab, but I've come up with a lab for Professor Holmes. He's who will be the sub, Michael Holmes. He'll give you that to do in class. It's a worksheet type lab. You can work together, but everyone's turning in their own. Okay, no multiple names. He'll take roll. I think you'll want to come to class on time that day. I'm going to instruct him to mark absence or if students were late. Okay, so I want to know that. And so you have a couple of things to turn in, including a lab that I'll give them. This mandatory lab, I want to bump it to Monday, so let me write that down. So that's a mandatory lab with an oral quiz, and I want to handle that. I don't want to give that to the fill-in guy. I would like to do that. So the wet lab. Mandatory blood typing. That will be moved to this day. Monday, that's the 28th. That's the one with oral quiz. Okay, so just to back it up. So the blood lab I've come up with for you to do on this Friday It's more of a worksheet thing. But it includes everything, including blood typing, and that's an opportunity for you to start to get that down, because I want this blood lab, the blood typing part, will do the whole thing. It includes blood typing. I want you to get ready for that. Okay. So this 1028 day, that's your mandatory blood typing day. And I was looking at the schedule. I think it will be better to flip these topics. I want to do lymphatics first, then immunity, just in terms of the length. Lymphatics is shorter. That'll leave us enough time to do the blood typing lab. So for 1028, for lecture, we'll do lymphatics. Oops. The other thing I wanted to announce is, okay, this quiz, I decided to cancel it. I'm not going to do it. Since I'm not going to be available this week, because I'm in meetings starting from today all the way to Friday, I'm not going to be available very much in my office. So I thought, it's not fair to give you a quiz. So, X that out. But we're still doing this lab that has an oral quiz, and you really shouldn't worry about this too much. How I handle it is, I'm going to give your group the quiz questions in advance. And then you'll have a chance to choose your own question. And you'll get to prepare an answer before I call you up there. Okay, so it's not a true quiz, but it's very important that I hear you reason out the blood typing correctly. Because, let's see here, on 10:30 Wednesday, couple more days here. I'm going to do the written portion of Lecture Exam 5 in class, and it covers blood typing. Lecture Exam 5, and it covers blood typing. So I'm already thinking about the next lecture exam. I know you're not. You're worried about lecture exam 4, because that's what's next. Of course you should worry about that first, right? You gotta prioritize. But I always gotta be a step ahead of you guys. So this is coming. All right, any questions on that? That'll be in class. Now the multiple choice portion I'll put on Canvas. Okay. So written portion in class, multiple choice portion on Canvas.
Is switching those two lecture days going to affect that test at all?
No. Because all I'm doing is I'm flipping immunity and lymphatics. Okay, but I always have lecture exam 5 planned for that day, the written part anyways. Okay, but what does the written portion cover?
Blood typing.
Did I already teach that?
Yeah.
So that part's not affected. Okay. However, lymphatics and immunity are covered on the multiple choice portion. So I'll make that available on Wednesday the 30th, and I'll make it available at least through the next day. Okay, so you have at least an extra day to study for that on Canvas. I think that's all I wanted to say. Is there any confusion? You guys have any questions for me on what's coming up? I switched a few things, but I tried to keep it the same to avoid confusion.
For the future, are all of our multiple choice exams going to be proctorium based?
No. 5 and 6 are. 7 I always do in class. When it gets to the end, I want to see you. Because if weird things happen at the end, I got to see you in person for the last exams. Any other questions? I'm going to go ahead and dismiss class. I know you're thinking about lecture exam 4. So let's get that done. I'll see you guys. I won't see you, but see you next time.